Okay, now we're going to talk about measures of variability, how much data are varying from one another, which is one of the most important concepts in statistics and math. We're going to look at two things, interquartile range and mean absolute deviation. So these are some, might sound like big vocabulary words, but they represent something that's pretty simple. We're looking for a single number that can tell us how spread out a data set is. Kind of like mean and median are single numbers that tell us what the center of a data set are. Interquartile range tells us how spread out a data set is, and mean absolute deviation is a different kind of a calculation that tells you the same thing. It's good to be familiar with both. So first, let's define interquartile range. So the definition here, the interquartile range is the distance between the middles of the upper half and the lower half of the data. Okay, so we'll think about that as we look at an example here. So here we have two classes, and these are the quiz scores from a recent quiz for Class A and Class B. So you can see Class A's scores ranged from kind of 78 up to 86, and Class B had kind of one section of students that were down here from 72 to 76, and another that ranged from 86 up to 92. Okay, and we're going to use these two examples to calculate this idea of interquartile range. And so what we want to do first is go ahead and find the median of Class A and its interquartile range. Okay, that's how we do it. The first thing we do with interquartile range is we find the median. So you may remember the median is the middle of the data. It could be one data point that's smack dab in the middle, or it could be that there are two data points in the middle and you have to take the average of them. So in this case, if you line up all the data points as we've done here, and you kind of divide it in half, you're going to find that the halfway point is about right there. Okay, it's not about right there, it's exactly right there, and that's between 80 and 82. And then when you have a situation like that where the median is between two of the data points, you take the average, or the middle. So you can see that the middle between 80 and 82 is 81. You can also calculate that by adding 80 plus 82 is 162 and dividing that by 2, just calculating the average here, and you get 81. So let's go ahead and write that. The median of this data set is 81. Now, let's go back to our definition here. What we want to do is we find the distance between the middles of the upper half and the lower half of the data. So now we have the lower half here and the upper half. We need to find the middle of each of those. So let's go ahead and find the middle of the lower half here. So we can count these up and find the middle data point, which is right there. It is an actual single data point. If it were two, we would do the same thing as we did with the median. We would find the average of those two. But this one, the middle data point that's smack dab in the middle there of the lower half of the data, is 80, and we call that the lower quartile. Just another vocabulary word so we can know that what it is that we're talking about. So there's a lower quartile there, and as you guessed it, there's probably an upper quartile, and that's the middle half of the top half of the middle of the top half of the data, and that's at 84. Okay, now we have the middle of the lower half and the middle of the upper half. That we have, those are called the lower quartile and the upper quartile. We just find the distance between those, and that is called the interquartile range. And that's 4, because 84 minus 80 is just 4. So this is a single number here that tells us about how spread out the data are. Now we say, well, gosh, is that a lot or a little? Well, let's compare that to Class B, do the same exact thing here, and see what its interquartile range is. And you can ask yourself first, is Class A more or less spread out than Class B? Well, probably we can see Class B is more spread out. So we'd expect the interquartile range of Class B to be larger. Let's see if we're right. So first let's find that median. It's right there. It's between 76 and 86. We have to average those. You can do the calculation. You find that the median is 81. Okay, those are 10 apart. 76 is 10 away from 86. So 5 is halfway, and that's 81. Okay, now let's find the lower quartile. That is at 74, and the upper quartile, which is at 90. And again, the way we'd find those is by just counting up the number of data points here and finding the middle one, and it happened to be 74 and 90. Now, you remember the interquartile range is just the difference, the distance between these two data points here, and you can see that that is 16. So Class A has an interquartile range of 4. Class B, much more spread out. It has an interquartile range of 16. Now, why is that important? Well, if you were to only calculate the median of these two classes, you would say the median of Class A's quiz score was 81, and the median of Class B's quiz scores was also 81. So the classes must be doing the same, right? They have the same median. Well, really, that's not the case because the picture of the data is much different. In Class A, most people are kind of clustered here around the median. Most people are understanding the material on the quiz pretty well. In Class B, some people are understanding the material really well, but some people are not understanding it nearly as well, and that could be a problem. So the median by itself doesn't tell the whole story. We also need some sort of representation of how spread out the data are, and we see that Class A, nice tight data set there, not very spread out. Class B, really spread out, which may indicate that there's a problem. Some students are not understanding the material. And that's why it's important to look at both the center and the variability, in this case with interquartile range. Now let's look at a different example, a different way of calculating how spread out data are, and that's the mean absolute deviation. So let's first start with a definition. The mean absolute deviation, which we'll call the MAD, is the average distance of the points from the mean, okay? So let's figure out why we call it this. So the distance from the mean or the middle of the data, that's called a deviation. So that's why we call this a deviation. And we call it an absolute deviation because if it's above or below, we don't care. We just care how far it is away. So we won't have negatives and positives here. We'll just have distance from the mean or middle of the data. And then we take the average of those, or the mean, and that's what the mean absolute deviation is. So that's why this whole fancy term here, you can just see that each part means something that you can understand. And we can abbreviate that as MAD. So let's go ahead and look at the Class A and Class B means first, because we're going to calculate those so that we can find the distance of each data point from the mean. So we won't actually do the arithmetic here, but if you were to add up all these data points right here, you would get 2,116. And there are 26 data points, so you divide by 26. Remember, that's how you get the mean. You take the sum divided by the number of data points. In this case, it's 81.4. Okay? Now, it's very similar, you can see, to the median, which was 81. So that's an encouraging sign that the mean and the median are somewhat similar. Class B's, if you were to add them all up, it's 2,126. That's all of these data points added up. There are also 26 students in that class. So you divide that, and that's at 81.8. So also very similar to the median that we saw there. So that's where we start when we're calculating mean absolute deviation. We first want to find the mean. And now we're going to find the distance of each data point from that mean. So what do we mean by that? Well, let's create a little table here. This is usually the best way to do mean absolute deviation. Actually, the best way is to put all the data into a spreadsheet. And you can use spreadsheets with statistics and save yourself a lot of time of doing calculations. But here we'll put it into a table so you can see what it means. Okay, so when we're looking at Class A here, you can see that there were 6 students who got a 78. So one data point is 78. There were 6 of them. And we want to know what's the distance from 78 to the mean of 81.4, remember. And if you do that calculation, you can say 78 minus 81.4, that's going to be a negative number, but you take the absolute value of that because we want the absolute deviation. And you see that 78 is 3.4 away from 81.4. So those data points are 3.4 away from the mean. And we can do that with the next data point, which is 80. There were 7 students who got an 80, and those are 1.4 away from the mean. Similar here with 82 was the next score right over here, and you do the calculation there. That's 0.6 away from the mean. Now we're above the mean. 82 is above 81.4. We still take the absolute value. Then when you get 0.6, et cetera, down through the table. So you can see that some of the data points are as far as 3.4 away, and that's below the mean, and some are as far away as 4.6 above the mean. Okay, makes sense? Now, what we want to do is we want to find, so those are all the absolute deviations. So we've gotten this part, the absolute deviation. We want to find the average or the mean of those. So we have to add all these up and divide by the number. Now, if we made a table for every data point, there would be 26 rows in this table, not enough room here on the video. So this is why I just said 78 is one data point, but there are 6 people there at that data point, 6 students who got a 78 on the quiz. So we have to multiply 6 times 78 plus 7 students times 80, et cetera here, and here's the calculation. So we'll multiply 6 students times 3.4, that's how far they were away from the mean, and then 7 students times 1.4, that's how far these 7 students were away from the mean. Then we'll do 5 students times 0.6, et cetera here. And then all of those, there are 26 of the students. So basically, again, we're saying how far was each data point away from the mean? Let's add all those up and then divide by the number of data points. And then if you complete that calculation, you can see that the Class A MAD here is, if you do all the math up here, you get 60 divided by 26, and you get 2.3. So that's the mean absolute deviation for Class A. Now let's look at Class B. Similar kind of thing here. We're going to say, okay, over here with Class B, there were 4 students who had a 72. So here's the data point of 72. Here's the 4 students. We saw that the mean of Class B was 81.8. So we want to say, how far is 72 away from 81.8? We do the calculation here. We take the absolute value. This would be a negative number otherwise. And we say that we see that that's 9.8 away from the mean. And these 5 students who got a 74, they were 7.8 away from the mean, et cetera, all the way through the table here. Then you do the similar calculation for Class B MAD. So you go ahead and say those 4 students times 9.8 is the first term here, plus 5 students times 7.8, et cetera, through here. Divide by the total number of students in Class B, and that's also 26, same as Class A. We'll go ahead and finish the calculation here, and we see that the Class B MAD was 202. If you add up all this in the numerator here, it's 202 divided by 26, and that's 7.8. So a lot of arithmetic to get to this point, but we see here, Class A, that this is a measure, again, of how spread out the data are. Well, Class A had the mean absolute deviation of only 2.3, not very spread out, compared to Class B, which had a mean absolute deviation of 7.8, much more spread out. So both of these measures, interquartile range and mean absolute deviation, give you a single number to demonstrate that Class A is not very spread out, Class B is very spread out, and that can be very important for the teacher who wants to teach these students.